If not, we'll continue. Please remind me, we had homework on 1.1 and 1.2. I forgot. Yes, we did. I remember now. Okay, any questions? Anyone? Okay, so in that case, I would like to continue with 1.3, which is the average rate of change of a function between 2 points. We did this on our first day of classes. I'm just going to share my screen directly. And so let's just practice. I have nothing to say about it. We already did this. This is nothing new. So this is, where is my, okay. So this is the average rate of change. And this is page 134, 135. So I would like us to choose a problem and work on it.
We do 52.
Which one?
52.
52, total revenue, excellent. So 52, and 52 is on page 135. Good. So we have a company named Fast Trends determines that the revenue in dollars for the sale of X iPad holders is given by R of X, which is negative 0.001 x squared plus 150x. Find R of 305 minus R of 300 over 305 minus 300. First of all, when we see this, what comes to mind? Is there something we discussed in the past that looks like this?
Was it the cost revenue function?
No, this is only the revenue. We only have revenue. Does anything come to mind?
The rate of change?
Yes, is the average rate of change of this function between 300 and 305 on the interval 300 and 305. F of 2 minus f of 1 over x2 minus x1. So that's the formula. It can be any function. F of x2 minus f of x1 divided by x2 minus x1. As you know, this is the slope of the line, of the secant line going through these points. 300 comma r of 300 and 305 comma r of 305. That's all we are asked to do. Before we calculate everything here, we go back to the measurement unit. So it says X from the sale of items, X items, and R is the revenue in dollars. So this measurement unit for the numerator is dollars, and this is for units. The reason I'm emphasizing this is because we always have to present the measurement unit. And I want you to understand that the average rate of change, or any rate of change, has two measurement units. Okay? So in this case, it will be the measurement unit for y divided by the measurement unit of x for x. So it's in dollars per unit. For example, if you ask me, you call me and I'm in my car and I drive and you ask me what is your speed, I'm not going to say that I drive at 60 miles. No, I'm going to have to say that I'm driving at 60 miles per hour. Every rate of change has two measurement units, one coming from the numerator, which is the y value, and one coming from the denominator, which is the x value. Okay, so now in order to determine these, so the average rate for this function, I'm going to plug the function in the graphing calculator. So in y equals, I clear, and I have negative 0.01, no, 001, sorry, x squared, and then plus 150x. And then I go with second and table, and I plug in 300, and I plug in 305. Okay? I go up, okay, and I see these values. Highlight them to make sure that you have the entire picture. So the 305 is 45659.98, and the 300 is 44910, and 305 minus 300 is 5. Okay, so again, what will it represent? The numerator is the difference in revenue between producing 300 and 305. So we're going to calculate this in a minute. The denominator is 5 units, basically. Okay, so the revenue in dollars per unit, if we manufacture not 300, but 305. So by changing from manufacturing or selling, in this case, because it's revenue, selling 300 versus selling 305, it brings us an amount of dollars per each unit of, and we will determine it right now. Okay, so let's see. I'm sharing my screen again, and let's calculate this. If you calculated it already for us, please give me the answer. 45659.98. It's dollars. I need to round up to 2 decimal places. 44910. And then at the end, I will divide by 5. So it's 149.996. So I have to, I'm going to write it like this first. So this is approximately $150 per unit. So between those 2 points, the average rate of change is $150 per unit. Any questions on this problem? Any questions on this problem? Let's look at another easy situation, just for a review, a quick review of the formula. So let's choose a problem from 16 to 20. And then let's move on.
Can we do 17?
Yes, with pleasure. Any. Okay, so let's look at 17. And this is my page 2, and this is 17. 17 says f of x equals x squared plus 2x, for x1 equals 0, and for x2 equals 6. So the average rate of change for the average rate between 0 and 6 is f of x2 minus f of x1, as we know, over x2 minus x1. Oh, I'm sorry. So the average rate between 0 and 6 is f of x2 minus f of x1 over x2 minus x1. Now, all I have to do is determine, because I have the denominator is 6 minus 0. 6 minus 0, x2 minus x1. But can anyone give us f of x1, which is obviously f of 0? And can anyone give us f of 6? How much is f of 0? Is anyone with me? Anyone paying attention?
Would it be 0?
Of course. Can anyone give us f of 6?
6.
F of 6.
48.
So it's 36, right? Plus 12, 48 indeed. Excellent. So then I have to write 48 minus 0, which is 48. So what is the rate of change? There is no measurement unit here because it's abstract. So we don't have to worry about that for this particular problem. So what do we get?
8.
Very good.
Yeah, 8.
No measurement unit because this, the y value and the x value don't have measurement units in this particular problem. Okay, so I think we are in the clear with that. The next step, we're moving on to page 144, just to get it ready. But I have a few things to explain before we look at examples. In 1.4, we are talking about close to, I don't want to mention what it is. It's differentiation, but I will explain because I want something from you before I mention the title. So there are two concepts, major concepts that we talked about so far in the last 3 weeks. A wild guess, or it's an educated guess, actually. What do you think? What will you say? Oh, the major concepts that we learned are two major concepts, not graphing, just major concepts that we learned so far.
Types of functions.
Say it again.
Type of functions.
That's true. That's true. That's a concept. Good. But something else, like major. Last time, for example, we learned something major. It's a major concept in calculus.
Were you talking about the
Yes. Limits. Perfect. I want one more that I emphasized from day one. Yes.
derivative?
We are not there
How do you
yet.
say it?
We are not there yet. We are getting there. So that's why I didn't want to put it here. Yes, that's the next step. So limits is a major concept. Major. What was the other concept that I emphasized for almost from day one? Other than graphing, piecewise defined functions.
Was it the difference quotient?
Thank you very much. Everything was important that we discussed in this class, but these were the major topics. Now, when we put these two together, this is when we get the concept of derivative. So you will never forget if you remember just this sentence. Two major concepts. One is the limit concept, and the other one is the difference quotient concept. They will give us the derivative together. But first of all, let's discuss what is this? It's a fancy word, but what does it mean before we put these together? Okay. You will understand. It's not a difficult concept. Other things will be more involving. Okay. So, derivative. Derivative. So let's take a look. Okay. So let's look at a function. Here's a function, f of x, and let's say it gives a revenue it gives profit, whatever you wanted it to give. And let's suppose at this point in time, I don't know, a particular year, 3 years from the moment we opened our business, you would like to know what is the rate of change at this point. Not the rate of change between 2 points, between year 1 and year 4. No. You are asking me, let's say I am your advisor, and you're asking me, okay, tell me, how is my company doing? What is my rate of change? What is the rate of change of the company, of the profit of the company right here? In order for me to tell you what it is, I have to calculate the slope of the tangent line at this point. If I manage to calculate the slope of the tangent line when x is 3, I will tell you the answer. I will give you the answer. If it's positive or if it's negative or if it's 0, who knows? But I will give you the answer. In order to determine the slope of this line, of the tangent line, we have to find the derivative function, the function called derivative of this. So this is the notation f prime of x. So this is not this function. It's a different function that gives the rate of change at this point, gives us the slope of the tangent line at this point, gives us the slope of the tangent line at this point, everywhere where the function has a rate of change. Okay? Functions may or may not have a rate of change. So the slope of the tangent line is also, I'm going to put in parentheses actually, the instantaneous rate of change. Remember the example that we looked at a long time ago? I'm driving from Baltimore to New York, and you call me and you say, what is your speed right now? Well, I'm giving you the slope of the tangent line to the graph of the distance when you called me. That's the instantaneous. If you ask me about the average rate of change, my average speed, I have to calculate the distance, I have to calculate the time I used to drive, and I'll tell you what the average rate of change or average speed was. But no, this time we want to determine the instantaneous rate of change at that point. The derivative of this function, once we calculate it, it will give us the instantaneous rate of change at this point, or the slope, which is the same, or the slope of the tangent line at that point. When I say that functions may or may not have a rate of change, what do I mean? Here's what I mean. At this point, it's called the cusp or corner. This function, at this point, it does not have f prime. It does not have a rate of change. F prime of x is dne. It does not exist at this corner. It exists here. There is a tangent here. It exists here. There is a tangent and it has a slope, but it does not exist here. Here's another situation. If the function is not continuous, at this point, f prime of x is dne. If the function is not continuous, the function cannot have a rate of change at that point. Here is another situation. At this point, the function does not have a rate of change. It has a vertical tangent. And a vertical tangent, the function does not have f prime. F prime at this point is dne. So if you ask me, determine the slope, the rate of change here, let's say at 3, I say, sorry, I can't. It doesn't exist. If you ask me, find the rate of change here, let's say at 1, I'll say, sorry, it does not exist. I can't give it to you. If you ask me, find the rate of change of this function at this point at x equals 4, I'm going to say, sorry, it does not exist. I cannot give it to you. Or any other corner. Here's another example for a corner. So these are the situations in which I said functions may or may not have a rate of change. When they don't have an instantaneous rate of change, when there is a corner, this is called a cusp, but it can be treated as a corner, when the function is not continuous, and when the function has a vertical tangent. So we still don't know how to calculate the derivative, but I want to look at a couple of graphs first. Okay, so let's say this graph. Does the function have a derivative, has a rate of change at this point at x sub 0?